In this solution, we're going to use the distance formula from a line to a point. So this formula that's given here. And this formula involves using a linear equation in the general form. And when we have the general form equation ax plus by plus c equals 0, we can use that equation. So the first thing is we need to construct the angle theta again. So what we're going to do is use the slope of 2 over 5 to get angle B in quadrant 1, and that technically is negative angle B. And when we add those two angles, it's the same as subtracting that angle, and we get that difference angle between the red line and the blue line to be angle theta. So that would represent that arctan 4 plus arctan negative 2 over 5, but instead of constructing negative 2 over 5 slope, we use a positive 2 over 5 slope. And that way we can see the angle there. And so once we've constructed that angle, we're going to use, since the formula uses the linear equation in the general form, we need to convert that red line. The equation of that red line is y equals 2 over 5x, and rearranging that equation, we're going to, into the ax plus by plus c equals 0 form, that rearranges into 2x minus 5y plus 0 equals 0. So we now have the equation of that line, and we can use the formula to find the distance from that red line to any particular point. And the point that we need is going to be 0.14. And the distance from that line represents a perpendicular distance. So what we're going to end up doing is find the length of that green line. And by doing so, the distance is going to be a perpendicular distance, which then allows us to construct a right triangle, this right triangle here, that involves the angle theta. So we're going to then apply the formula to get the length of that line, that perpendicular line. So we now have the point. The point is going to be 1, 4. We're going to plug it into this equation. So the a coefficient is going to be 2. The x coordinate plus b is going to be negative 5. So minus 5. Y1 represents the y coordinate of the point that's in question, plus 0, all over the square root of a squared plus b squared. Okay, and then plugging in the coordinate in question is 1 and 4. Okay, so we plug that into x1, y1, and then we work out that distance value. That's equal to the distance. This length here is going to be the d. So when we plug that all in and calculate it, in the numerator we end up with 18, okay, or in this case negative 18, the absolute value. And that's all over square root of 29. So the distance is going to be 18 over square root 29. So that's the length of d. And now since we have the length of d, we do have the length of the hypotenuse of d, which is root 17. So now we can then use that green right triangle that we've constructed to be able to find the value of sine theta. So we can then say that the sine of angle theta, based on that right triangle, is going to be the d that we've calculated, 18 over root 29, and over the hypotenuse, in this case this is root 17, and putting that all together, we end up with 18 over square root 29 times square root 17, and that works out to be 493, which is the same solution we got from the other methods. So this method involves using an equation of that coordinate geometry equation that I've given here, the formula, for the distance from a line to a point, it allows us to calculate that perpendicular distance, which allows us to construct that green right triangle, of which we know the hypotenuse, and involves angle theta, and we can calculate sine theta from there.